Hi, my name's James Titcumb. I've been writing PHP since around 2002, programming since before that, a bit of an open source fanatic, whenever I have time, whatever that may be. I'm available to hire through Rove. Gary mentioned Rove a couple of times in his talk this morning. Basically, we're a group of freelancers dedicated to writing nice, good quality software and hopefully improving some older stuff as well, as we shall find out shortly. You can find me on Twitter and Mastodon and, of course, the Rove Discord server. If anyone wants to join that and hang around, you don't have to be have like a specific interest in freelancing or anything. Just if you're interested in tech, we have like a home automation channel as well. It's quite popular and so on. And you get to chat to us and other like-minded people as well, and get lots of useful information. Gaming as well. There's a gaming channel, and people play the video computer games on there and so on. As you can tell, I do that a lot. Okay, anyway. And when I do play video games, it's terrible, so maybe don't ask me to play video games. So anyway, picture this. You've joined a new team. Excellent. First day on the job, right? You're feeling great. You're excited to dig into some new awesome code. You grab yourself a cup of Yorkshire tea. And you start settling into the work. Your elephant's at the ready. Let's go. I'm so excited. Wait. What's this? Something catches your attention. You think. What is this code doing? That doesn't seem right. What's going on here? What is this? Who would do this? Oh, gosh. OMG, it gets worse. What is happening here? What in the fresh hell is that doing there? Why would you encapsulate global state in a singleton? Why is the container available in a static object? No! Where did it all go wrong? What life choices led me to this inescapable hellfire pit of doom? What did I do to deserve this monstrosity spawned from the very bowels of existence to be thrown into my brain and mist and to decimate my very fabric of existence? Why am I screaming into a fluffy toy? How did I get here? They asked me whether I could reverse a binary sort tree in the interview. I thought I'd be working on complex algorithms. Instead, I'm stuck with this horrible code. It's awful. It's legacy. I will start with a question to you all. What does legacy mean? Because, and don't worry, it's a rhetorical question. I'll answer it. There is an elephant in the room. Don't worry, that's my one terrible pun allowance. So legacy can mean, right, old code. Code uses outdated patterns, obsolete stuff, but it's still in use. Wish we could get rid of that. It's difficult to maintain. It uses old frameworks and libraries that haven't been updated for centuries, perhaps. It's fragile, untouchable code, right? Systems that are really expensive to replace. But it can also mean working code, right? Code that still provides value, and also code that you've just written, okay? To quote my friend and colleague Sergeant Vranat, code can be in two states, in production or useless, okay? A common cause of so-called legacy code is like fast iteration, right? Imagine something like a startup. You want to build something very quickly, right? That's the nature of the game, right? So you're going to use like a RAD framework, some snazzy tool that generates a load of code, some libraries that take your pain away and fix the problem in like seconds. It's fine. You know what? But the important thing is doing this, it produces value, right? Yes, you're cutting corners, and invariably you're probably going to be producing technical debt. But if the product is successful, you're left with this legacy, right? You've now looking back and looking at all the corners you've cut and be like, oh, wish we hadn't have done that. But it's okay, right? This is okay. Another cause of so-called legacy code is years and years and years of stability, right? Sometimes an application has been running for years. You've made small modifications here and there. You've added new features that they've been asked for. You haven't looked at or touched old features unless they had a bug in them. And you'll see that over time, inconsistent styles, inconsistent implementation practices, and so on have been introduced. Right? You went out to a conference, you learnt a new thing like 6 months ago, and then it became not fashionable anymore. So now you're stuck with it because it's in production. There's also dead code, and of course, probably untested code in very old stuff before testing was fashionable. But this is okay as well, because you are producing value, right? And this is okay. I would like to propose that legacy does not necessarily mean something is bad. It doesn't mean it's broken. It doesn't mean you have to refactor it and delete it or whatever you want to do, right? It's just there. It's doing its thing. And for a very long time in my career, you got to refactor everything, right? But this isn't really the way, right? We're obsessed with refactoring it, refactoring code and things like that. This talk is not about refactoring code, right? It's about living with your legacy code, right? Hence the title of the talk. Hopefully happily, right? That's the goal, okay? And I would say that sometimes it's better just to leave things alone, right? If it ain't broke, don't fix it, right? Someone somewhere said that, I guess. I don't know who. So software that's been running for years or even decades, and I've worked on projects that have been running for decades. It doesn't necessarily mean it's inherently broken just because it uses outdated patterns, outdated methodologies, and some framework that isn't used these days, MooTools or something, I don't know. People still use MooTools, I think, maybe? I don't know. So how do we tackle legacy code? Or really, it's just existing code, yeah? Legacy is surrounded with this stigma, right, that it's bad. But it's not, it's just existing code. So there's two main topics I'm going to discuss today. First up, sort of general skills, right, working on your project. When I was learning to program, I learned to write code in my bedroom as a young teenager, and I thought, this is great, I don't have to talk to humans, I can just rock up in my bedroom and write a load of code. That works great. So turns out that's not the case. It's actually probably the opposite. So this was the hard part for me, is to learn about sort of communication and things like that. So first up is like how we communicate to the business. And by the business, I mean, like, for me, it would be like my clients, the people I work for. For you, maybe that's your employer if you're employed, or maybe you're freelance as well. I think, in my experience, one of the most important things when talking to the businesses or the clients or whatever is managing expectations, setting and managing those expectations. Yes, estimates are a part of that, and yes, estimates are a complete mystery, and we'll never get it right, but it's okay. But most businesses are pretty reasonable and understand that things come up that we cannot anticipate, right? Things will always change. Maybe the scope has changed through no fault of your own. Maybe we've made discoveries that mean that, oh, actually, this is a much bigger job than we thought it was going to be. It's fine, because we communicate with the customer and we manage their expectations. As soon as we get like an inkling, this isn't something quite right, we can discuss it openly with the customer. And more often than not, they will appreciate that you've come to them first, rather than getting down to the end of the contract and being like, oh, by the way, we need another 6 months to do this thing. And then they're going to be like, could you not have said something sooner? So we're looking for good open communication channels with like people like product owners, management, executives, whoever your kind of your interested stakeholders are, right? And then there's also your peer communication. And that's mostly going to be your tech folk, right? Devs, tech folk, testers, people like that. Other teams as well at your company that are, maybe involved in what you're trying to do. And I would say always be open with your team, right? There's always, very often there's like office politics and nonsense like that, right? So obviously this is quite a blanket statement which won't always apply. But, try and be open and honest with your team, especially like I often end up being in a team lead position. I'm like, I want to be as open as possible with my team so that they know where they stand on things, all right? I don't try like just getting them to work a certain way. It's just nonsense. Let's just talk like humans and and be humanable to each other, right? An interesting thing, like many folks are moving remote now. I've been working remotely for lots of years now. So this is, I'm no stranger to this, but folks who are usually used to working in an office and, maybe now their company's gone all remote or something like that, or mostly remote. My favorite tools are video calls and actually having your camera on. Not everyone is comfortable with this. Certainly I wasn't. Like someone said to me, "Oh, you should turn your camera on." I'm like, "No, no one wants to look at this." But it's very, very helpful because it allows you to read body language much better. And yes, you can probably usually only see the head and maybe shoulders or something like that. So you can't see like their body stance, how they're stood, and things like that. Which are, even if you don't actively think, "Oh, I'm reading how this person," they're closed up or anything like that, right? But it gives you a lot of cues as to how people are receiving your feedback, or whether they're understanding what you're explaining to them. I do a lot of mentoring, and if I can't see the person I'm explaining something to, they could be asleep, right? For all I know, if their cameras aren't on, which is fine. If it's really boring, maybe I'll switch it up. Maybe we'll do something different. Let's just not sleep. Pairing as well is a very useful tool. I do this quite a lot, working through a problem together, and quite often it'll be the better developer, or the more knowledgeable developer on that particular topic should be not the one driving. So the one driving should be the one who's trying to learn this new skill, for example. And of course, our tech chats. We've got Slack and IRC and Mattermost. Does anyone still use MSN Messenger? No? Oh, okay. I don't even know if it's still running. I think they sunsetted that a while ago. Anyway, in your team, agreeing direction where we're going on things, right? Discussing strategy for what pain points are, agreeing the direction that you want to go and approach those particular issues. It's great where a company or your team even has like a good tech lead who can help mediate those kind of discussions, help guide you and make decisions in that team, which is great. And obviously it's quite important to, well, not necessarily obviously, but I think it's important to have buy-in from the whole team on things like, what tools are we going to use on this project? What are our development processes and practices and so on? How are we going to go about doing code reviews? How are we going to go about setting up a CI pipeline, assuming you haven't already got one, and things like that? So, using that agreed direction, we can define these processes well. So we can have an expected typical workflow. And quite often, actually, this is a document that I will produce for a client quite early on. It will be like, how do we research specifications? If you tell us, you as in the client says, I would like this thing to be built, right? And I don't know about you folks, but sometimes you have anything from like pages and pages of detailed specifications up to like a single sentence. And trying to decode what they actually want out of that can be challenging sometimes, right? So we need to do some research, analysis, and so on, come up with proposals on how are we going to approach this particular problem. We can set out in writing, what are our team expectations for coding style, linting tools, testing strategy, all that kind of stuff. Stuff that you can argue till you're blue in the face. Oh, this tool is better, but this tool is better because it does it differently, and it doesn't really matter as long as we all agree. Okay, let's do that. How are you going to do pairing? How are you going to do code reviews and so on, and all that kind of stuff? And write it down and document this stuff. And then your client will understand what your flow is as well. They might not care, but it's there if they want to read it. I produce reams of documentation for clients, and they invariably never get read. But the point is, we've written it down, we've defined that, and we can refer back to it. So yes, things like this should be documented alongside all your technical documentation as well, of course. The goal always, and I ask my team to call me out on it as well, is to turn tribal knowledge into written down documentation. And especially with like big corporations, enterprises, none of this stuff gets written down. It gets passed down by word of mouth, which is really useless, right? And someone new joins the team and they're like, okay, how does this thing work? Okay, let's get on a call, let's talk you through it. Okay, so this new person then learns all this stuff. But then we're going to have to do the same exercise all over again the next time a new person starts, because we haven't written that stuff down. So, whenever I explain something to my team, and it's not a written down thing, they will often say, we should document that, which is great. And I'm like, yes, let's do that. And then we write it down. All right. For me, I think a great place for writing documentation like this is within the code repositories that you're working on. Quite often, we will just make a folder called docs. We'll fill it with a load of markdown with some useful information. The reason why we put it in the code with the code repository is that it's there, right? You've got no excuse for not updating the docs because they're right next to the code that you're also updating or adding a new feature to, or whatever you're doing. You can, of course, publish it, right? For example, GitHub pages, GitLab pages, that makes this kind of process incredibly easy. Somewhere it can be easily read is nice. One of my clients heavily uses Confluence, for example. The Confluence, rather frustratingly, is behind a VPN. So we've actually developed a CI pipeline that takes those docs and writes it into Confluence. There is actually an open source tool on the Rove GitHub if you want to look at it. It's called DocBook Tool, which is nothing to do with DocBook format, but hey, not the best naming perhaps. One last thing about documentation is to also consider the target audience, right? When we're writing documentation that's intended for the client or the business, let's try and avoid using like jargon tech talk, right? We want the target audience to be able to read and understand those documentations so that they are useful to them and not just be like, I don't know what this thing says, right? Conversely, if you're documenting something that is intended for your peers, your fellow developers, then fine, put in the technical information. But don't always assume that they have background knowledge. Like, for example, we write unit tests. Okay, well, new dev joins the team. What's a unit test, James? At least some basic stuff, like if you want to find out about unit testing, go to this website, for example. That kind of thing. Make it useful for the reader. So good documentation takes a lot of thought. I'm not saying I do it perfectly all the time, but constantly trying to keep that evolving is very important. So when people read through documentation, they say, oh, what's that? And then I will amend it and fix it and make it better, right? So it's sort of constantly evolving thing. And if it's in with the code repository, it makes it easier to evolve that because it's right in front of you already. So now the technical stuff, right? A bit more comfortable in this area, perhaps. This is tools like coding standards tools, static analysis, testing tools, and things like that. First up, reading code. For me, certainly, this is probably one of the most challenging things to learn. And I think that reading code is far more important than writing code at the end of the day. The more code you read, the better you get at it to a degree. You want to get to the point where you can be like, oh, I bet such and such wrote that code just because of the way it's done, not because it was done badly, of course. But you'll notice the way people, certain team members do things, all right? So refactoring, rewriting code is only useful to the person actually writing that code, or people if you're pairing or whatever, mob programming, however you want to do it. Everyone else in the team still has to read that code and understand it. So writing code, it's okay. I'm not talking about laying things out with understanding code. I'm talking about like getting a mental model of how that code actually works. And it takes a lot of like thinking and understanding to try and get that into your head. So how do we get good at it? Well, practice. Like I said, reading lots of code will hopefully make you better at reading it. We can do that by reviewing code, for example. Reviewing open source pull requests, right? Just rock up to your favorite project. They've probably got a bunch of pull requests waiting to be merged because no one's had time to review them because, hey, reading code is mentally intensive, right? If you have pull requests and merge requests at your place of work, review them, yeah? Even if it's not necessarily something you've worked on or have been asked to work on, like just take a few minutes, look through what changes have been made, try and understand what's happening. You don't have to necessarily leave feedback. You can just review it and be like, oh, yeah, okay, I understand that, move on. But, try and make your own notes, figure out what's going on. Using a step debugger as well is another way of doing it. I find this incredibly useful for understanding what code is doing. You can read through code and be like, oh, yeah, this looks like it's doing this and this and this. And then you run it, and it does something you didn't expect. Right? And so a step debugger, like Xdebug and whatever other debuggers exist these days, I don't know. There was a Zen debugger at one point. But yeah, set up Xdebug, run the code that you're going through, and try and understand, see how the values change. You can play with the values, change them on the fly and things like that, and make your code do different things each execution as well, which is fun, right? There's also, writing tests. I know, it's mad. But you can write tests to characterize what code is actually doing. You can be like, okay, this function looks like it's doing this thing, right? If I give it some kind of input, it should do some certain things, and maybe have some side effects, right? Quite often we'll have side effects for older code, and we're like, oh yeah, let's just do this, and then it will affect this other thing later down the line, and all that kind of stuff. And then there's understanding the business. And by this, I mean, like, what are we actually trying to achieve here? This is not like the technical aspect. This is understanding the business. What are the goals of the business, right? How does the business make money that you're working for, right? Because that is an important thing to understand, right? And that helps you to prioritize, like, how do we want to work on this particular problem? What does your product do? Why are we doing it, Most businesses exist to make money because that's just how the businesses stay afloat and how they pay your paychecks, right? So, let's not shy away from it and be like, oh, money is a taboo topic or whatever. It's not, right? Businesses are there to make money. Even charities, they're there to make money so they can improve something. They're perhaps more altruistic than some companies, but hey, they're all there to make money. So let's try and do this in the most efficient way possible. How can we use the technology to achieve those goals of the business? So a success factor which leads to, I think, everyone's happiness, right, is a balance of our developer experience and of the business value, okay? And by developer experience, I mean the ease at which we can do our work, how happy we are when we open up our IDEs or text editors and be like, that's bad. Reducing those frustrations where, you dread opening your computer in the morning because, You don't want to work there. That's a bad developer experience, right? And it's not necessarily like the company or the company values or ethos or whatever book of things that we have going on in our companies. It could be that the code is just difficult to work with and frustrating, right? So we want to increase our productivity by being happier working on the code that we work on, right? That's important. And by business value, I mean helping the business meet its goals, right? Of making money, however it does that particular thing. So happy developers that work to deliver the business value means that the business will also value the developers in return, usually. Admittedly, it doesn't always work that way. But when that balance is right, then everyone is a lot happier, I think. So, should we refactor? We need to weigh up options, like what's the actual maintainability of the code? How easy can it change? What's the cost of not changing that code? What's the cost to developer experience, for example? We need to weigh up the risk of breaking things when we refactor things, yeah? We can mitigate that somewhat by having tests. So maybe we should write some tests before we refactor. I always recommend that if we can. We also need to weigh up the value to the business, right? That's a risk in itself, of course. If you refactor something and break it, especially if it's like the core thing that the business makes money on, we're in trouble, right? If it ain't broke, don't fix it, right? Sometimes refactoring is necessitated by a new feature being added or a bug being fixed and so on. But just consider if it's really needed. We don't always have to be refactoring because refactoring itself is a risk. Don't just refactor for, oh, look, this new cool framework came out, so we should start using it straight away. All right. That's usually not a great decision to refactor, okay? Tech reasons are not necessarily the best. We're obsessed with refactoring a lot, okay? We like doing it, and we don't always do it for the right reasons. And I would say that sometimes a refactoring exercise probably could have been a reading code exercise, trying to understand it better, maybe produce some documentation for it, especially if it's difficult to read, and so on. Okay, so we've worked out we do need to refactor a part of our application. Limit the scope, all right? Ask yourself, what is it specifically that we want to improve about this? Why? And do the minimum needed to achieve that improvement. And we iterate. We do it, break it down into as small chunks as possible, all right? The cost of change is high. On a piece of software that's been running for decades, right? If it's working, right, and you refactor it for some reason, right, the cost of that change is going to be high because the more changes you have, the more risk there is, it's potentially going to break things. And so it goes back to that balance, the developer experience versus the business value, right? So make a good plan when you do these refactorings, right? Don't just be like, oh yes, let's tap, tap, tap away on your keyboard and it's now lovely code, except it doesn't work as well. Or like a feature that used to work now doesn't work anymore. Oops. Don't try and tackle everything all at once. You know, as I said, sort of break it down into small steps, baby steps, iterate on it. You'll get there in the end. It's the long game, right? And if you're in it for the long haul, then you will see this sort of model working better, right? So going back to sort of tooling, investing time into automating checks as much as possible almost will always pay off, right? I've never seen like introducing a tool like static analysis not pay off dividends. Coding standards is an easy one, right? Pick a coding standards tool, PHP Code Sniffer, PHP CS Fixer, pick a coding standard, probably PSR 12 or whatever is around. I actually picked Doctrine Coding Standard. It's like really, really lots of fixes and things like that that I don't really have to worry about coding style anymore when I use that. It just does it, right? All these tools, they fix code for you, so you don't have to do it. So it's a no-brainer, right? Static analysis, and to quote myself, which is important to do in your talks, right? I think that static analysis is probably one of the best things to happen to PHP since Composer. It's like, if you've never used static analysis before, maybe you don't really understand about types and stuff, and you're just like, it's just a string. You put string in the function, and that's what it gets, and you don't really think much more of it. But it's like, starting to use static analysis tools is like a gateway drug to understanding types better. And I would say, don't just enable the stricter static analysis and then try and fix all of the problems at once, because it will drain your soul. Instead, like both tools like PHP Stan and SAM and so on, you can crank these up to the strictest mode, but then create a baseline and say, okay, we're going to start with all of these issues, we'll accept them and say they're fine, and then when you run it, it will only flag issues in new code that you've written that was not previous, new issues that appear. And so you can fix those ones, of course. And then you can go back and sort of work on all the existing issues that are in the baseline. And over time, hopefully, try and shrink that baseline. It may not happen, right? Sometimes you will be stuck with that baseline forever. Or, I sometimes have never seen the end of it, because there is just sometimes too many issues. And sometimes you just don't need to refactor the code, right? I use PHP Storm for my my PHP coding, and you can set up like specific severities for static analysis, and I make it nice and bright blue so I can see it very clearly. And it flags up all the stuff in the baseline as well. So whilst I'm coding, I can see, oh yeah, it doesn't understand this type. That's okay, because I can fix that easily. And then invariably, we start playing static analysis whack-a-mole, which is where you fix an issue, and then suddenly 10 more issues pop up. And I'm seeing some nods, but those are the people who have also encountered this, because they started understanding how the types work, and they were trying to use the tool and be like, okay, now... And the reason why this happens is because you've defined something better, you've defined a type better, so that the static analyzer can understand that type, which means that you've uncovered all of the usages where you're using it wrong. So sometimes they're legitimate bugs, sometimes it's just because there's some more typing missing, or type hinting, type declarations missing. So sometimes it's actually okay to also increase the baseline, but don't just blindly do this. Don't just be like, fix the thing and increase the baseline every time, because you'll just end up with pain. So, testing, right? Grumpy programmer Chris Hartjes, for a very long time in his career, was like, why aren't you testing? And he gets all grumpy about people not testing and so on. But you know what? Guess what? Testing is important. Many times I've joined a team or project, and they just don't have any tests. Nothing. Right? Sometimes they'll have something, but it's poor, right? And you could be like, well, it's probably better just to start again, perhaps, or maybe work on that and improve it. Ultimately, good tests are better than bad tests, and bad tests are still better than no tests at all, right? So you've got something. Making a testing habit going forward is basically every single change, like a pull request, merge request, or whatever, it should be reviewed and be tested. And if you don't have tests, your team should be able to say, okay, we're not merging this. There are, of course, times like if something's on fire, you need to merge some code quick because everything's on fire. Maybe that's okay, but go back and add tests later, right? And talking about code reviews, like your whole team should be able to review code, not just one person. Similarly, not the whole team. You don't have to, especially if you've got a large team, you don't have to get the whole team to review everything all the time. It's very time-consuming, right? But also, if it's one person reviewing all the time, they will become a bottleneck, because you'll be like, oh, I need this review. Oh, they're on holiday this week. Now what do we do? And just twiddle thumbs? No, of course not, right? So try not to have the same people reviewing code all the time, and encourage less confident reviewers, people who aren't as confident with reading and understanding code. Encourage them to review and speak up about things. They may just want to understand what you're doing better as well, right? So empower them to be able to ask questions about things. Because reviews, to me, are not gatekeeping. We're not trying to say, this is bad, no merch, right? We're trying to get a discussion going about the code changes that we're making. So we're not trying to block people from doing work. We're trying to make it better, right? We're trying to improve the quality. So we can implement policies about like how we write code, right? They're not always going to be clear-cut. We can make policies like, well, we don't make any changes without tests. We don't merge a pull request if it's red, if the build is failing, right? We have to run the static analysis tools or the coding standards tools and things like that. We want to strive for consistency to improve the quality. Even then, there's always caveats, right? We need to be able to make decisions to break those policies sometimes, because we live in the real world, and it's not always cut and dry about how we do things. But only do things if you understand the impact of what you're doing, and you understand, I'm cutting this corner, and this means blah blah blah, right? You have to understand the consequences. And some policies are a bit more flexible. Like I mentioned earlier, increasing the static analysis baseline is sometimes okay. Deleting tests, sometimes okay. Not usually, but there's always, and we'll have a think about this in a sane way rather than just saying, oh, but the rules say this, it must be done this way. Okay. A great example of taking feedback from code reviews is Kieran worked on a new change on a project that we were on. It was reviewed by a team member who sat there, so I have to be careful what I say now. The team member recommended not merging it, right? Because Kieran had tried something, and it did work, he achieved the goal, but it had some really major drawbacks, right? So never be afraid to delete your own code. More often than not, usually it's not this drastic, right? We don't usually have to just throw it all away and start again. Usually it's just like, let's make some improvements. But the relevant point that I'm trying to make here is that, Kieran and Marco had a grown-up discussion, right? They weren't criticizing each other and saying, oh, your coding is rubbish and you should feel bad, right? Marco wasn't criticizing Kieran as a developer or as a person or anything like that. I saw the review, I read through it, it was very considered. Both sides put together the pros and the cons, and they were like, okay, I can understand this probably isn't the best solution. Let's go back to the drawing board in that particular case. It was amicable, respectful, and professional. And we see so often, like in code reviews, like someone will say, you're rubbish, and it just all kicks off, doesn't it, right? And it happens so much on open source projects as well, which is really sad. And it puts people off. And you're like, oh yeah, but if I contribute some open source, I write some code, and then someone's going to say that on my merge request, it's going to make me feel bad, And we don't want to feel bad. We want to feel good about the change that we're making. So, how do we approach no tests? Well, work out what the business value is, right? Make money by doing X, Y, Z. Write a happy path test to ensure that particular thing happens, basically. For example, just starting from the very beginning. Maybe you've got an API or a web UI, run it somewhere, point your single test at that and say, okay, make it do the thing. Use maybe something like Selenium or WebDriver or something to run it. This is not the best testing. I'm not advocating this as a best practice for testing here. I'm just advocating to get something off the ground, right? Before all the best practice testing people are like, oh, that's not the best way to write tests and things like that. I'm not saying that this is the best way to write tests. But point it at your application running. Get a single test running that will look at your application and make sure it works. Just one happy path. That's the first way to get in your tests started writing in your project, right? You could use Bhat, for example. It's not strictly BDD, doesn't matter, right? It solves a problem, okay? You could write characterization tests and say, okay, this class does this in this way. There's pros and cons to this, right? But the point is you're not writing beautiful tests that are worded perfectly or form a beautiful test triangle, whatever. Right? The point is you're making sure that we're not breaking the critical functionality. And something is better than nothing when it comes to testing. It's not a forever solution, right? And often when you write tests in this way, you'll be like, okay, well, this is really brittle and it fails all the time because we keep changing CSS classes and whatever we pin to in Selenium is now broken. All sorts of things can happen. Characterization tests, for example, they'll fall out of fashion very quickly because you'll be like, okay, well, we can characterize it, but we're not actually testing how this thing works, right? But yeah, it's a starting point, right? And then you build up your day-to-day, then you can focus on your nice test pyramid, things like that. And every time you fix a bug, add a new test. Every time you make a new feature, add a new test, right? To go with that feature, make sure the feature works, and so on. Limit the scope of what you're doing, right? Don't just write write these bad tests forever, okay? You want to try and improve this stuff, right? And as you learn more about testing, especially if you've never done testing before, don't worry, I'm not going to make you put your hand up or anything like that. But if you've never done testing in your application before, don't worry about doing it in the best practice way, all right? Start off doing something and then learn as you go along to improve that, yeah? That's a much easier journey, I'll promise you that. And I mentioned earlier, should we delete tests? Yeah, sometimes. If you've got tests being covered in two different ways, like the old rubbish way you used to do it, but now you've got these new shiny tests which are much better, yeah, delete the old tests. If they're not producing value anymore, it's okay. As long as you've got that test coverage, i.e. not lines of code covered, slightly less important metric, but as long as you're testing what the application is supposed to be doing, that's kind of what we're looking for here. And of course, make sure the tests are run in continuous integration. There's no point in writing all these tests if they're not going to be run in an automated way every single time, because otherwise we'll forget to run them or something like that. We should be looking for this. There's red or green feedback. And I mentioned earlier, we shouldn't be merging anything that makes the build pipeline red. It should always be green. If you're starting from a point right now, I've been on projects before where the CI is just constantly red. I put in a change and be like, hey, let's see the results. Oh, it's red. Well, that's no use. I've broken something. What have I broken? Oh, it's something completely not related to the change I made. Not so useful. But yes, automate all of those checks. CS checks, tests, static analysis, security checks. You can run database migrations in your test suite to make sure that they work, because otherwise they'll just, maybe one day they'll blow up, right? Open API documentation. If you're writing an API, have that generated automatically, however you want to do it. I mentioned earlier about documentation, like farming it out to Confluence and places where people can read that documentation. Do that in CI, right? CI can do loads of things for you these days. GitHub Actions make this kind of stuff so easy. Even GitLab and things like that. All the ways of doing things, like you can throw Docker containers at the things and all over the place, and you can get loads of CI stuff done. And it's much quicker than running this stuff by hand, because you don't have to do it. You can go and do something else more productive. It's great. So, to summarize, legacy is not necessarily bad, right? It's just existing code. If it's in production right now, it's probably producing value, unless it's dead code, in which case, probably just delete it. Yeah. And how do you tackle your existing code base? How do you live with this? Remember that we don't always have to be refactoring all the time. Communicate with your peers, the rest of your business, in the best way you can. Treat them like humans, not like angry people all the time, right? Produce lots of documentations about everything. Document all of the things. Even if you think, yes, of course, no one's ever going to read this thing, right? It means you've understood it by writing through this thing. And then if someone does eventually come and read this thing, hopefully it will help them. That's what we're going for. And keep that documentation updated. Learn to really read code and read and understand it. Oh, that's it. Maybe I've run out of time. Okay. Oh, there we go. Okay. Use tools to improve your code quality. Characterize your critical functionality as quickly as possible. If you have no tests, get in there and just write something to get you off the ground. Yeah, and then build up your test pyramid and things like that, and make sure you're using CI to its absolutely effectiveness. Thank you very much, folks. Appreciate you coming to my talk, and don't forget to join the Rove Discord. Thank you.